Hello and welcome to another one of D's ADD videos. Today I'm going to be looking at exponential derivatives, the concept, and since it's such a short concept I'll probably squeeze in a few basic examples as well. To do an exponential derivative, let's say you have a e to some function here. The derivative always will have that e to the function in it. You just multiply it by the derivative of whatever's up top. Okay? If there's a number to the box, whatever that number is, not e, you have to ln that number and then you multiply by that same formula right there. Okay, so that's the concept for the derivatives of e's. So let's see a few of the basic ones in action. Here I have a problem in which I want the derivative. So if I want the derivative, f prime or dy dx can be written, and it's going to be the derivative of what we have up top that's your d box right there times your e box, what we had originally. So the derivative of that would be 4x plus 3 times what we had originally. Okay, pretty straightforward, hopefully. That would be your answer. Here I have a chain rule. When I do the derivative of the box, in this case, is going to be the square root. Actually, I'm going to go ahead and rewrite that as 1 minus x cubed to the half. It's just using your good old algebra rule. You should know this by now. Just in case you forgot, here's a friendly reminder. That's going to equal x to the a over b. So if there's nothing here, here's a 1 understood to be there, and if there's nothing there, there's a 2 understood to be there. So that would be times your original e to the box, which would be 1 minus x cubed to the half, or square rooted, however you want to rewrite that. So this derivative requires a chain rule. You bring it down, rewrite what you have, subtract 1 times the derivative of the inside. All that is just for the derivative of this expression right here. Then you got to re-multiply your original e box, right? So e1 minus x cubed square rooted, or 1/2, whatever you want to write. You could stop at this point. Most professors aren't that picky as far as their cleanup goes, but there's no sense in having this negative exponent there, so some people will count off for not getting rid of your negative exponents, and all you do is just bring it down to the bottom and make it a positive exponent, and then there's your answer right there. Okay, and that's x cubed, and that's a 1/2, a positive 1/2. Okay, last one we're going to derive here is this. This one's pretty straightforward. You're going to do an ln of the number, in this case the number is the 2, times the d box, which the box is 3x, times the original problem, 2 to the 3x. So that's going to be ln of 2, the derivative of 3x is 3. Now I'm going to write that 3 in front because I don't want you to be tempted to multiply the 2 times 3, because this is ln of 2, which is 0.69 blah blah 35 something or other, and we have the 2 to the 3x, and we're done with that one. Okay, so practice, practice, practice. You can see these ones aren't too bad. You might have them in a product rule or quotient rule. I'll do a couple of those examples later. Make sure you check out those videos as well. And of course, as always, you gotta practice, practice, practice. That's the most important part to all of this stuff. If you don't practice, it will not stick. I hope I've cleared things up for you. Thank you, and have a nice day.